Hey everyone, we're back again. We're doing 1.6a notes this time on angle vocabulary. So our goal for today is to be able to describe these different angle pairs and then use those to find different angle measures. So we got some new vocab words. Go ahead and flip to your 1.6a notes if you haven't, and let's get started. So the first one, complementary angles. No, it's not two angles that give one another complements, although that would be entertaining, right? It's two angles that add to 90 degrees. All right, so that's what it is, a picture of this. There's a couple different ways we might see something like this. We know they're adding up to a right angle, so we might see a right angle where one of these angles is 20 and the other is 70 or something like that. We might also see two separate angles that are not adjacent. Maybe this one's 30 degrees and this one over here is 60 degrees. Either way, those are two examples of complementary angles. Get this to focus a little better. All right, maybe it's just not going to. Come on, you can do it. Okay. Well, we'll work with what we've got. All right, the next one, supplementary angles. So complementary was two angles that add to 90. Supplementary is two angles that add to 180 degrees. So two angles that add to 180 degrees. Okay, there's a couple different ways that this can look, but the most common thing you're going to see when we're just talking about something that's supplementary would be something like this. Maybe this angle's 120 degrees, and this angle over here is 60 degrees. Together, those angles add up to 180, so that makes them supplementary. Okay. The next one, linear pair, is very similar to supplementary. It's two angles that are supplementary and they're also adjacent. So two angles that still add to 180 and are adjacent. So if we don't remember what that word adjacent meant, that was just two angles that are sharing a ray. They're touching one another along one of the sides of the angles. They have a common side. So if we had something like this, where one of these angles is 45 degrees and maybe the other one is 135 degrees, if they're along a line together, like if there's a straight line and an angle that kind of comes out of it, those two angles are considered a linear pair. And if you think about it, linear, line, the words kind of go together, right? So linear pair, if they're on a line together, they're touching, if they're adjacent, and they add to 180, they're a linear pair. All right. The last, or actually second to last, sorry. Second to last new vocab word for today is vertical angles. So vertical angles are angles that are across from one another when formed by crossing lines. All right. So the picture that we should get from this, with angles that are across from each other when they're formed by crossing lines, is if we've got lines that are intersecting like this. Vertical angles are the ones that are across from one another, either direction that you go. So we have two pairs of vertical angles here. We have the pair this way. These would be vertical angles with each other. And then we also have going with each other the other way that are across from each other. these two. And the interesting thing about vertical angles is that they're congruent to each other. So this is going to come in really handy later on. We can say vertical angles are congruent. And we're going to start using the congruent symbol a lot for to talk about congruent and so that you don't have to write the word congruent a whole bunch. So if you haven't seen the symbol a lot yet, the equal sign with the little squiggle above it, that means congruent. And so we're going to start using that notation quite a bit. So that's a good one to learn and to remember and to use. That's the congruent symbol. All right, and so vertical angles are congruent. So kind of moving on from there, our very last vocab word, we're going to make a new box down here for it. Instead of doing these examples over here, we're going to do examples on the homework worksheet. So make a little box down here. We're going to talk about the last vocab word for today, angle bisector. Okay, an angle bisector is a line, segment, or ray that divides an angle into two congruent angles. Okay, so for example, a picture of something like this happening. Let's say we have this angle here. And in the middle of it, there's an angle bisector. If this is a bisector, we know that the angles that it splits it into are two congruent angles. We know those would be the same amount of degrees. Maybe they're both 30 degrees or something like that if the whole thing is 60. So just like we knew with segment bisectors, that if something's a segment bisector, the two segments on either side of that bisector are congruent. Same thing happens for angles. If this is the angle bisector, then the angles on either side of it are congruent with each other. They're the same size angle. So if I were to tell you that the whole thing is 60 and this is a bisector, then we know that these are each 60 divided by 2. If I were to tell you that this is a bisector and that this one is 30, then you know that this one's also 30 and that the whole thing would be 60. So there's a lot of ways we can use that. Okay, so go ahead, turn the page with me. Your homework is actually going to be part of practice B. We're going to turn to the next page where it says practice A at the top. And together, we're going to do a couple of these problems from practice A just to get some more practice with these. Okay, so here we go. First one, name a pair of adjacent complementary angles using this picture over here. So adjacent tells us that they're going to be next to each other. Complementary tells us that they're going to add to 90 degrees. So I'm looking for two angles that are next to each other that add to 90. So I start looking around and going, okay, is 58 plus 23 90? No, not quite. Well, what about like 55 and 67? No, that's going to be too big. That looks obtuse, right? What about these two, 55 and 35? It just so happens that that one works out. So I want to name that pair of angles. So one of them is FJG. So angle FJG. And the other one was GJH. So that'd be this one here. All right, so those ones are adjacent and they add to 90. So they're adjacent complementary angles. All right, the next one they want is non-adjacent complementary angles. So we want the same thing. We want complementary. So we still want adding to 90. But this time they're non-adjacent. So they're not going to be touching. So maybe we want one from this picture and one from this picture. Pause the video for a moment and see if you can find anything from over here that adds to 90 with something from over here. Okay, hopefully you paused it and gave it a try. The ones that I found were this one here, the 23, along with the 67 here. So 23 plus 67 is 90. They're not touching. They're not adjacent. So I'm going to say it's angle CAD for the 23 and angle FJE for the 67. All right. Last one from this section. We've got a pair of non-adjacent supplementary angles. So supplementary tells me that we're adding to 180 this time. We're adding to something a little bit bigger. Let's see. For this one, you may end up having to use more than one angle here. You might have to add up several. Like EJH here, this whole thing. You might want to use that, or you might want to use BAD, this whole angle here. Pause the video for a moment and see if you can get anything that adds up to 180 from these. Okay, hopefully you paused the video for a second and tried it. The two that I found were angle EJH, because all together, if you add this one up, we should get, let's see, that was 67, 55, and 35 all together. This one is 157. And this one over here, 23, if I add that to 157, we should get 180. So angle CAD will be my other one that goes with it. So angle EJH and angle CAD are going to be my non-adjacent supplementary angles. Okay, looking at the next two, in 4 and 5 here, it says angle 1 is a complement, so we know that it adds to 90 with angle 2. If angle 2 is 36, find angle 1. All right, so for this one, super simple. Once you figure out that it's supposed to add to 90, just subtract away the 36. 90 minus 36 gives us 54. So this tells me that measure of angle 1 is 54 degrees. We can do the same kind of thing with our next problem. It says it's a supplement of angle 4. So that means it's going to add to 180 this time. So we just have to subtract away the angle that we know. We have to go 180 minus 75, which gives me 105. So that tells me that measure of angle 3 here that I'm looking for is 105 degrees. Okay. Kind of moving forward from here, ones like number 6 and 7. We'll go over number 6 together. It says that WXY and X or YXZ are supplementary angles. And it tells you what these angles are. We want to find the measure of the angles. So if they're supplementary, that tells us they add to 180. So the equation that we want to make to go with them is we want to add these two together and set it equal to 180. So we're going to go 6x plus 59 plus 3x minus 14 equals 180. And we're going to solve that equation. So first, combining our like terms, we have 6x and 3x. That tells me we have now 9x. We have 59 and minus 14. 59 minus 14 is 45. So 9x plus 45 equals 180. Then we're going to subtract 45 from both sides. We get 9x equals 135. Lastly, we divide on both sides by 9. 135 divided by 9 is 15. So x equals 15 is part of my answer for number 6. But then we have to go back and plug it into each of the angles. So I take 15 here, and I go 6 times 15 plus 59. And I go 3 times 15 minus 14 for my final answers. So we should get here 31 degrees, and here we get 149 degrees. Those will be my 2 answers for number 6. Okay, and I know this page is getting a little bit busy, so when you go to do your own assignment, if you would like to use extra scratch paper and just staple it in, or there's also a page or two at the back that you could use that's blank pages, feel free to use those so you can kind of organize your work and stuff like that. Okay, for ones like 8 through 10, we're using this picture right here, and it's going to ask some questions about the picture. The first one says, identify the linear pairs that include angle 5. So here's angle 5, and we're looking to make a linear pair with angle 5. And actually, so if we look at the lines that angle 5 is on, there's really only one. 5 and 4 make a linear pair. They make this straight line here. You could make a linear pair with 5 and then this other angle over here, but it's not really named all on its own. So on this one, honestly, I would probably just say angle 5 and angle 4. That would be a linear pair that includes angle 5. Next one, are angles 3 and 5 vertical angles? Well, we just drew the lines that make up angle 5. Are they the same lines that make angle 3? They are. Looking at these two, the same lines that I drew that made 5 are the lines that made 3, and they're across from each other. So we'd say yes. Those are vertical angles. What about 2 and 4, though? If you look at the lines that make 4, is it the same as the lines that make 2? No, right? The lines that make 4 are these two. Angle 2, though, is made by this ray right here. So that's why this one would be a no. Okay, so that's kind of an example, some examples of the types of problems that you're going to encounter on your homework today. If you flip back to the other page, not that page, the practice B page. Looks a little crazy now. Let's see if I can find another copy that doesn't have marker all over. There we go. All right, so if you look at practice B for 1.6, your homework for today is just numbers 1 through 11. So for 1, 2, and 3, you're using these pictures. For 4 and 5, it's the same kind of ones that we did on the other page that were also 4 and 5. 6 and 7, again, same kind as we did on the other page that were also 6 and 7. And then 8, 9, 10, and 11 are the same kind as we did on the other page that looked like 8, 9, and 10. Okay, but this time we're using this picture. Give it your best shot. Have fun. If you have questions, feel free to email or ask when I'm back. Have a great day.